Hey, Walter Sorrells back with another Knife Makers Friday 5. Today, tips for better drilling. So today I'm going to be going over some drilling hacks. You know, drilling is one of the most important facets of knife making, I guess really in metalworking generally. So today I'm going to be going over some tips and tricks to up your drilling game. Also, we might be having a special guest joining us. We'll see. First, a couple things related to the channel. At long last, I've got the Sorrells brick actually in stock on sorrellstool.com. That's this little gizmo right here, linked to a previous video where I explain what this thing is, what it does, why you might want one. But anyway, if you've been waiting around for a Sorrells brick, they are available on Sorrells Tool right now. And if they're all gone by the time you get there, Pop's Knife Supply has a whole bunch of them too. Speaking of Pop's, upcoming video, I went out to Pop's to shoot another Pop's project of the month yesterday. Had a bunch of fun. They're great guys out there. Joey and Dirk both pitched in and showed some knives that they're working on. And so it was just a fun thing generally, and that video should be out next Friday. Have a bunch of nice little tips and tricks for your knife making. Finally, I'll be posting the plans to the build that I did last week for this knife right here on my Patreon page. So all my Patreon members have access to all the plans for, you know, all these builds that I do. Those will be going up, I don't know, next couple days anyway. So as always, to my Patreon supporters, thanks a ton. We wouldn't be able to do what we do here without you guys. Okay, so I'm just gonna jump right into it. Drilling hacks here. You know, it seems like drilling is the simplest thing in the world. You know, here's a nice little DeWalt battery powered drill. I love this drill. I use it all the time, but do I actually drill any holes with it? Very rarely, very, very rarely. Only, you know, worst case scenarios where I can't put something into a drill press. So tip number one, and this may seem a little bit obvious, but it's a good starting place. If you don't have a drill press, if you're using a drill like this, my first tip is just, if at all humanly possible, get a drill press. Drill presses are the foundation of good drilling. There's just a ton of things that makes them an improvement over this. The first thing is that a drill press gives you a nice, stable platform, the table. And what that means is that every time you drill, if you do everything correctly, then you're gonna get a 90-degree hole. All right, I'm not gonna belabor that point. I could talk all day about drill presses, but enough said on that point. Okay, so tip number two, put a light on your drill press. So if you got a drill press that's already got a light built into it, you don't need to do this. But you know, you can buy these little gooseneck lamps off of Amazon, eBay, whatever. They're super cheap. You can get them down at Walmart or Home Depot or whatever. Magnet on the back, you pop them on there. You can move the little gooseneck light around. Got a tiny little LED light in there. Plug them in wherever, and you'll be able to see what you're doing so much better, and that'll make your drilling better. Tip number three, hold downs. So the natural inclination when you're drilling on a drill press is to just slap whatever you're drilling onto there and start drilling. But you'll get better results if you have something that holds that object, whatever it is. A knife blade is the typical thing that knife makers are drilling, or maybe handle scales. But just slapping it down there and start drilling, there's some difficulties that come along with that. And so I always recommend having something there to hold your work. Now, there's a whole variety of things that you can use. Simplest thing is just some kind of clamp. C-clamps, welder's clamps, you know, just almost anything that will firmly hold it down on the table is going to help you. However, You can do better than C-clamps and stuff like that. I used to use those. You sort of have to turn the table to the side and then stick the C-clamp here, and that means that if you drill through, you're going to drill into the table, so you have to put something underneath it. There's a better way than just using clamps. Clamps are better than nothing, don't get me wrong, but there's some better alternatives, the first of which is a vice grip type clamp. Fancier and, you know, even pretty simple drill presses have usually little slots on the table. So the bottom holds into that little T-nut slot, and then I'll clamp it down, and that'll assure that you're drilling nice and straight. So that's one reasonably cheap, reasonably simple way to support things better on your drill press. There's a better way than that, though, in my opinion, and that's to use a drilling vise. So a drilling vise is just a vise that's made to sit on the table of your drill and hold things nice and square and level so that you can drill them better. Okay, so let me add another little footnote. One of the things that can happen, and it's particularly nasty with knives, is that a drill bit, especially the bigger the drill bit is, the more prone they are to doing this. A drill bit, as it's drilling down into the hole, you get a little web in there and it grabs hold of it and starts spinning that knife around. Knives are made to cut things, your hands are sitting there, obviously bad things can happen. So you want to avoid having knives spin around like that. And so the more mass that you have holding on to that thing, the less likely that it's going to helicopter. Now, if you have a small milling vise or drilling vise, they can still grab hold of them, and sometimes you'll spin the whole damn vise, and that's really not cool. So the bigger and the more massive the drilling vise is, the less prone it is to helicoptering. Now, another facet of the drilling vise is they usually have little cutouts that, you know, allow you to attach the thing to the table to those same little slots that I was talking about with the vice grip type hold downs. What you can do with those, what I typically do is I just attach one of those. If you attach the whole thing super firmly to the table, then it's hard to adjust to get the hole exactly where you want it. So what I typically do is I just attach it at one point on one corner, and then and I have it very loose so I can move the thing around. So it'll slide in the slot and then it'll rotate around that point that it's anchored. You don't need the thing bolted super firmly to the table. All you're trying to do is keep it from spinning around. So what I'll typically do with that little drilling vise, if I'm using it, is just keep that one corner attached and situate it however I want it, and then start drilling. So to me, there's one step up even from a drilling vise, and that is a milling vise. So milling vises are obviously, as the name implies, designed to go on mills, usually like a Bridgeport or something, but you can get nice big Kurt vises that are as much as anything intended to go in CNC machines. It doesn't really matter. The point is that a milling vise, A, is made typically to a level of greater precision than a drilling vise, but also, and this is particularly true of the Kurt, but there are other systems to accomplish the same thing. I don't want to get too far into the weeds of this, but basically, if there's any play in the jaws of a vise, which there always is, by the way, what will naturally happen is as you tighten it up, the unfixed jaw, the movable jaw will cock up like that, and it won't go completely square. And so there's some little tricks for, you know, on milling vises, on drilling vises for keeping that nice and square, but it's something that vices are all prone to. A Kurt vise in particular, but there are other systems for milling vises, has a particular and Kurt originally patented this process, I think, but it has a system in there that causes as you apply pressure so that the vice jaws are coming together, it actually creates a downward pressure so that vice maintains exact parallelism to the bottom of the vice, which then is parallel to the table, and assuming your spindle's trimmed up correctly, it gives you an exact 90-degree angle to the spindle and the drill bit. So you can get Kurt vices used. They're super expensive. Just just full disclosure, Kurt vices are ridiculously expensive. They're beautifully made. There's a reason they're expensive, but you buy a brand new one, they can be $700, $800 and up. However, you can go on eBay and find them for, if you really look around, maybe $250, maybe $350. I bought the one that I have on my mill drill over there a long time ago, and it was kind of beat up looking, but mechanically perfect shape. So you get one of those, it's a lifetime thing. You'll have that thing literally forever. Your grandchildren will still be using that thing if they want to. And it'll keep everything nice and square. It'll keep everything from moving around. They're just beautiful pieces of equipment. If you're willing to make that investment, you will never regret it. Okay, so next tip is use this stuff. This is tapping, it's called tapping fluid, but it's not very fluid in this particular case. You can get cutting fluids, you can get cutting and tapping fluids, you can get tapping fluids. All of them have kind of slightly different applications, and some of them are really made for automated machinery. And so anyway, bottom line is, this is a very popular kind of cutting fluid and or tapping fluid. And I use it in my shop, and there are plenty of other kinds. They're all worth using. So the bottom line here is you can drill better holes, and you can get much more life out of your drills if you use tapping fluid. So there's no great trick to it. Dump out a little tiny drop of it onto your hole or your drill bit. You can also use a little thing like this. You got a cheap ass little brush that goes in there, and you pour the fluid inside there. It's a kind of waxy, thick, goopy, oily sort of material, and it lubricates the drill bit as it's drilling, and it makes your drilling better, and it makes your drill bits last longer. I use tapping fluid just about every time that I drill through steel. And in fact, even stuff like brass, I'll still usually use it. Hey, there he is. All right.
What are you doing, man?
I'm actually filming a video right this minute. Hey, so why don't you come on over here? Just walk into my video and look, I'm ambushing you, but if you don't feel like it, we'll edit this out. But just stand here and introduce yourself and tell everybody why you're here, because I think it's an interesting little story.
Absolutely. So. Hey, my name is Jeff Parrish. I represent VSM Abrasives. Nice product placement there. Actually known Walter for several years. Got connected with the guys at Pop's Knife Supply. We do a lot of representation with them on our product line. Walter is good enough to have been give us a lot of good feedback on our products. And that's kind of what I'm here today for. We've got a new structured abrasive material, trying to sort of attack the market. And everyone knows the Trizac brand, and they know what that does. We're very eager to get his feedback on that, and that's kind of why I'm here today, to see what we can do for this gentleman.
Well, very excited about it. You know, like Jeff said, we've known each other for several years now, and you know, he's given me the opportunity to try out several different VSM products. I got a bunch of VSM belts sitting back there in my grinding shop, and you know, I'm just always excited. You know, this is something that I always talk about. Every time I talk about grinding, every time I talk about belts, I always say every belt does not solve every problem, And it's super important to test new belts. You know, I always say every time I order belts, I try to remember, just order one belt of something that you've never tested
Yes.
before. And it's amazing how, you know, sometimes you get it and you're like, oh, this thing's crap. And then you hang it up somewhere and you're trying to solve some problem and some belt's not quite doing it. And you're like, let me try that other thing that I tried, and it solves the problem.
Absolutely.
And so I'm super excited to be trying these out because, you know, there's always something that you can do better, and a lot of times a belt will solve that problem. So, all right, well, we're going to take a break right here. Jeff and I are going to run in the back and do some stuff, then I'll come back out and finish up this video.
Thanks, Walter.
Anyway, super happy to have you here.
Absolutely.
All right, well, I just got finished with a fantastic meeting with Jeff back in my grinding room there. He was showing me some new products that VSM's got. And, well, I'll bore you with the story of that on another occasion, but we had a really interesting chat about, I mean, you wouldn't think you could talk for an hour about abrasives, but we did. So anyway, I mentioned the issue of helicoptering. Let me jump back to that for a minute. The reality is that if you just want to quick and dirty punch a hole in something, you don't necessarily want to go through all this rigmarole, sticking it in a vise and screwing around with getting it exactly in the right place. Sometimes you don't need that. And so in those cases, you may just slap that knife right on the table and start drilling holes, and it's going to be susceptible to helicoptering. So a simple way of fixing that is just to clamp something on the table. A bunch of different ways of doing it. You can put a little bar stock in there. You can just put a C-clamp in there. But as long as it's situated in the path of the helicoptering, then when that drill bit grabs hold of the drill, it's just going to whip around, smack into that fence that you've made, and it'll stop it from helicoptering. Another little tip, and this was something that was brought to mind by my trip out to Pops yesterday. Almost everybody who has made knives has run into this particular problem. You drill a hole in the handle, and then you get a piece of pin stock of some sort, a little piece of brass or a piece of stainless steel, whatever it might be, micarta, and you're going to drive that down through the hole, and you know that'll be the pins that hold your handle on. Well, what happens is that pin stock was maybe made to 0.251 diameter, and the hole that you got is 0.250, and so the pin won't go through the hole. The worst situation here is where you did all this stuff, you got the pins ready, and you're like, oh yeah, I'm just gonna drop those things in there, and you start slathering 3-minute epoxy on something, and you start to drive those pins through the handle to attach your handle to the knife, and they won't go. And the epoxy's, you know, curing on you, and now you're freaking out because you just can't get there from here. If you use a bigger size drill, you'll avoid this whole problem. So, you know, there are a variety of little strategies for this, but basically you can buy oversized drill bits. If you go to Granger or other suppliers of industrial gear, they'll sell oversized bits that are like 251, 252, 253 for a 1/4 inch drill bit. And those are super handy. They're also letter size drills, like an F is just slightly bigger than 250, I think. Bunch of different ways of doing it, but the bottom line is it's a good practice as a knife maker to have some oversized drill bits and just routinely, when you're drilling holes in your handle scales or your tang, drill them a little oversized. You know, most knife making supply places like Pops will sell you those kind of drill bits, and they'll save you a ton of anguish. Okay, another important point. In machining, we always talk about feeds and speeds. So what this means basically is how fast you're spinning a tool and how fast you're driving it into the work. Now, if you're using CNC machines like mine sitting over there, you program all this stuff into the machine. And so it's really important for you to know exactly how many revolutions per minute you want to go and how many inches per or millimeters or whatever per second or per minute you're driving that tool down into the work, or sideways if you're using a milling cutter. So with a drill bit, the manufacturers will tell you if you're drilling cast iron, you want to have thus and such feeds and speeds. If you're drilling mild steel, thus and such feeds and speeds. The closer you get to those correct feeds and speeds, the more longevity you're going to get out of the drill bit, and the more effectively you're going to be able to drill holes. So one thing that I have to mention about any kind of drill press, or most drill presses, is that they're mostly variable speeds. Some of them you have a rheostat that you can change and it'll infinitely vary. Some of them you just have to move belts around, but most drill presses do have a variety of speeds that they can run at. And so the more that you can tune your drill to the kind of material that you're typically going to be drilling, the better. And you know, one solution, the way, you know, the sort of professional way to do it is every time you put a particular kind of material in there, you change the speeds on that drill press, and you're always going to be doing it at the correct feed, or the correct speed. Feed's a different issue. I'll talk about that in a second. But the issue here is that it takes a lot of time to change those belts all the time. What I recommend doing is figuring out a good speed for drilling steel. Set it to that and just leave it there. It's going to make it slower drilling through wood. It's going to make it slower drilling through plastic. It's going to make it slower drilling through brass. But guess what? It'll drill through those materials fine. And so rather than spinning it too fast and doing it at a speed that is natural for wood, say, and then burning up your drill bit every time you try to drill through the tang of a knife, keep it at that lower speed, and then, you know, it's just going to take you half a second more to go through a piece of wood, and just live with that. So here's where people tend to get into trouble with drilling, is they drill something, they burn out a drill bit, and they think, ooh, I better lighten up on my pressure. So the next thing they drill, they're like, and they're kind of, you know, just monkeying their way through it. Drill bits hate that. You actually want to be engaged. You want to have the cutting edge engaged in the material through the whole cut. Anytime that the drill bit just starts to spin and burnish the inside of that column that you're drilling out, it overheats the drill bit. It'll work harden the steel often. This is a big problem with steels like 1095. And it just is pushing that cutting edge, you know, just skating the cutting edge along this abrasive surface and screwing up the edge. None of those things are good. So what you want to do is, once you start feeling that drill bit go into the material, you want to just keep feeding and feel it cutting till you come out all the way out the other side. If you're pecking away, you're going to run into problems. There's a technique called peck drilling, which is appropriate for certain kinds of materials and certain depths and all that. But if you're just going through the tang of a knife, you just want to go all the way through that thing and be done with it. Stopping in the middle is where you run into problems. So it's a kind of feel thing, and over time you'll start to feel, you know, get a feel for it. But I can tell you, in my own case, when I first got started, I did not have anybody around to teach me this, and I just was like, and I burned a lot of drill bits because of that. Keep a nice steady pressure. You're not trying to kill it, but you want to see chips coming out the whole time. Cutting, and then it's out the other side. And there's a certain feel that you have with every drill bit that'll tell you that it's cutting. And if you got that feel, then you just keep feeding, and keep that steady pressure on there, you'll be okay. All right, we're gonna wrap it up there. Thanks for stopping by. This thing ran much, much longer than I intended it to, so I'm gonna try and edit it down to something that's a little more digestible. Anyway, really enjoyed this episode. It was good seeing Jeff, and the whole drilling thing is really very important in knife making, so hope you enjoyed that. All right, guys, thanks for stopping by, and keep on making those knives.